Alright, so this crappy videoing type is my last resort because of the snow and other unforeseeable incidents. So, I'm hoping that this way you will accept it this way. I'm not sure, but I hope so. So, the first problem that I decided that I needed to do was this one. And it is the problem where one truck's traveling one way and it leaves an hour before the other one. The one leaving first is going 80 kms and the one that's leaving second is going 60. So my first mistake on this problem was the fact that instead of doing 80 times t and getting 80t, I got 8t for some reason. And the second problem was the fact that I decided to subtract them and do a bunch of other weird stuff when I should have added them. I didn't realize that one was going north and one was going south. I just assumed that they were both going the same direction. So, let's see, where is it at? This is how it should have looked. Should have set it up with the 80 and the 60, and then this t, and then this is t minus 1 because this one left an hour later. So then you multiply those together, and you get 60t minus 60. And then this is 80t, like it should be. So then you add those together, and you get 80t plus 60t minus 60 equals 150, which is the distance you're trying to find. You're trying to find the time that they reach that distance apart. So then you subtract the 60, or add the 60, and you get 210. And then you add the two t's together and get 140t. And when you divide 210 by 140, you get approximately 1.5 hours or 1.5 hours for them to reach that distance apart. Alright, number 2. Let's see. Solve the system. There, see it? Okay, so the issue with this one was, after I slaved away over it for forever, instead of adding the 15 and the 10 together, I subtracted and got 5, which completely messed the whole thing up. So, what I should have done is first you pick two of the systems and you put them together. Let's see, where's it at? Here we go. You put these two together and you try, where's it at? Here it is. Put those two together and you're trying to use one of those variables that can cancel out. So I had to times the 3y and everything in that system by -1 so that the y's would cancel out. And then when you do all that, it leaves you, and then you add the x's and the z's and the variables together, and you get 3x plus 3z equals 6. So then you pick two other systems that you want to use. So I picked those two. Right. It's so hard to do this backwards. Those two right there. The -2x and the 4x. And so then, in order to make it easier for myself to get the 3x plus 3z equals 6, I decided to get rid of the y's so that it would be ready to set up. So I times the top one by 2 and the bottom one by -3 so that the y's would cancel out. And when you do that, you get -4x plus 6y minus 2z equals 10, and then you get -12x minus 6y minus 15z equals -45, if I'm reading that right upside down. And then once you cancel out those and add them all together, you get -16x minus 17z equals -35. And when you line that back up with the 3x plus 3z equals 6, you want to times those together so that one of them will cancel out. So I times the -16x by 3 and then the 3x by 16. Giving me -48 minus 51z equals -105. And then when you times the bottom one together, I don't know where that work went. When you times the bottom one together, you get 48x plus 48z equals 96. So then those two cancel out, and then you're left with -3z equals -9. So you divide that by -3, and you get that z equals 3. So then when you plug that back into an equation, like the 48x plus 48, and you change the z to 3 equals 96, and you work all that out, subtract the 144 from 96, and then divide -48 by 48, and you get the x equals -1. And then once you plug that back into one of the original equations, like this one, you get, where's that? You'll figure out that x is y equals 2, z equals 3, and x equals -1. Because when you plug the two, or when you plug those other two back into one of these original systems, and then you work them all out, you get that the y equals 2. Alright. My next problem, if I can find it, was to divide that. And I just completely messed up on this whole little boxy thing right here. Because I know that you're supposed to take you take what you're dividing by, and you have to add in the variable that's like missing. So you got the 0x to the third. And then you have your x minus 2. So you take the 2 and you change the sign and you put it in this little shelf right here. And then you write all the other variables down up here. But instead of dropping it at first, I just times it and dropped it down. And I forgot all the negatives as well. So then when I fixed that, you drop it down. 3 times 2 equals 6. 6 plus 0 is 6. Times 2 is 12. Minus 6 is 6. Times 2 is 12. Minus 4 is 8. Times 2 is 16. Minus 2 is 14. So then you put it back into the equation and you start with the x to the third because you get rid of the x to the fourth. And you get 3x cubed plus 6x squared plus 6x plus 8 plus 14 over x minus 2. And that is the answer to that one. Alright, my next problem was to factor x to the 6th minus x to squared. And honestly, I just really didn't even know how to do this problem. I know that you were supposed to, try to even it out, but then I did, for some reason, I squared the x squared minus 1, and it just gave me a whole bunch of long different answers, and I just kind of went with the one that I thought was the best. But then when I revisited this, and I fixed it, you start off with the GCF, and you get x squared, parentheses x to the 4th minus 1. So then you pull the x squared down here, and then you do you factor that, and you get x squared minus 1, x squared plus 1. So then you keep the x squared plus 1 and the x squared down here, and then you factor out the x minus 1, and you get x plus 1, x minus 1. So then your final answer is x squared, parentheses x squared plus 1, parentheses x plus 1, x minus 1. So that's the answer to that one. Then the next problem was kind of similar. It was x to the 6th minus x to the 3rd. And for this one, I thought you were just supposed to simplify all of them out. I didn't remember that it was, square the first, square the last, multiply and change the sign. But then once I figured that out, I factored out the GCF, and you get x to the 3rd, and then parentheses x to the 3rd minus 1. And then when you do, you put the x minus 1 in this little parenthesis right here, and then you square the first, so you get x squared, square the last, which was -1, so you get plus 1, and then you multiply those two together, which would give you negative x, and then you change the sign, so you get plus x. So then your final answer is x cubed, and then x minus 1, x squared plus x plus 1. Alright, my next problem was this one. It's a quadratic formula, and you have to solve by using the quadratic formula. And my issue was when I did the 4a y equals negative b plus or minus square root of b squared minus 4ac. When I did the c, I forgot to drop that negative down. And so it made this seem like it was 4i plus or minus the square root of 192 over 8, but in reality, it was actually 4 plus or minus the square root of 192i over 8, because when you plug in the numbers and you actually do the negative, then it gives you 16 minus 208 and it gives you negative 192. And this, the negative 4, or the negative b is actually negative, and it like cancels out, if that's nice. Yeah. Anyways, so then you get 4 plus or minus the square root of 192i over 8. Dun-dun-dun. Alright. Alright, so the next problem that I did was this big boy right here, which has been confusing me ever since we started doing it. I feel like you explained it, and I just forgot, because I know we went over it, but I never really understood how to do it. I just kind of tried to do the flowers, the power, the root is the root the first time I did it, and I ended up getting up some weird number like 8 to the 130 because I tried to times all of the fractions together. But in reality, when I asked someone and tried to ask them for their help, they told me that you had to do the square root first, or the square root first, then the cube root, then the fifth root. So then I got, you square root 64 and get 8, and then you do the cube root of that, and it gives you 2 square roots of 5. So that one was actually a lot simpler than I made it out to be, which was a relief. Okay, the next problem that I did was this bad boy right here. Yep. Gotta love those absolute values. So I just kind of guessed on this one too because I really wasn't sure what I was supposed to do. I thought that maybe x would be an element of a real number system for some reason. I don't know. Obviously I didn't show any work, so I can't really explain why I thought that, but going back over it, I realized that first you gotta simplify. So you subtract the 4 from both sides and get negative 15, and then you divide it by negative 3, which gives you 5, and you can't forget to change the sign right there. So then you have x plus 4 is 5. So then this handy dandy thing that I forgot you could do, where you put the negative 5 is less than or equal to x plus 4 is less than or equal to 5, where you put that in the middle and you put the 2 5s on the outside. I forgot we could do that. So then when you subtract the 4 from both sides, you get negative 9 is less than or equal to x is less than or equal to 1, which would look like that as a graph. It's beautiful, isn't it? Alright. The next problem that I missed. So many papers. Okay. So the next one that I missed, if I can find it. No, that wasn't it. That one, which is just like that other one that we just did, but I was barking up the wrong tree. I did something weird and end up like reversing it somehow. I think I forgot to change the sign up here after I divided, but after I fixed that, I subtracted the 2 and got 12, and then you divide the 3 and you get 4, and then you have to change the sign, and then when you put the x plus 4 in between the 4 and negative 4, and then you subtract the 4 from both sides, you get negative 8 is less than or equal to x, which is less than or equal to 0, which looks like that on a little graphy doodly thing. And the last one, last but not least, is this one, which I ended up just messing up the order of the operations that I should have done. I had the idea right because the parent function, of course, is the square root of x. So I knew how to graph it right here. But instead of doing shifting it left, then flipping it, and then moving up 4, I flipped it, then shifted it, and then moved it up, which I shouldn't have done. So then, if I would have done that, let's see. If I would have shifted, and then flipped, and then moved up 4, it would have been right up here, and going this way, instead of being down here. So now I'm going to try to draw that really quick. I don't know if I really can pause this. I'm kind of scared too because I don't want to have to restart the whole thing because I'm pretty sure this is my last problem. But I'm going to do this really quick and then I'm going to pop back in and show you what it looks like. I'm going to regraph it. Alright, so it ends up flipping the parent function upside down like this, only it's up here. So it's up, yeah, it's up there. So it ends up making y, let me look at this. It ends up making y less than or equal to 4 instead of less than or equal to negative 4 over here. And the x ended up staying the same, but it messed up the y. So that was the problem with that problem. Alright, well I hope that you accept my video in this form. I couldn't work them out as I went along, but I worked them out and then showed them to you. I wanted to record it on my phone, but then my phone memory was messed up, and yada yada yada, snow days, blah 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 blah. So anyways, that was my math project video, finally done. Thank you for your time, etc., etc.